Starship full stack for the final test. The most difficult technical challenge remains at the next launch. Musk revealed, "Welcome everyone to the next exciting installment of Elon Musk's signal." Breaking news, folks. The stacking of rocket modules for Starship 4 launch has just been completed, marking a significant milestone towards the wet dress rehearsal prior to the official launch. Starship could be flying again as soon as next month. However, what technical challenges lie ahead for SpaceX in the next launch? Let's explore and follow this thrilling journey in this video. Starship, SpaceX's fully reusable interplanetary transport system, also the most powerful rocket ever built. Despite losing prototypes in its first 3 test flights, SpaceX swiftly iterated on designs and pushed forward with bold testing campaigns. Recently, SpaceX completed stacking Starship 29 onto Super Heavy Booster 11. This marks a crucial step towards the 4th integrated flight test within the next 3 to 5 weeks. The upcoming days will be tense as SpaceX conducts a series of tests to ensure smooth operations before the official launch date. One of the toughest challenges is the wet dress rehearsal, simulating a full fuel load. This process acts as a final check for actual fueling, allowing SpaceX to verify the entire ground system and eliminate any potential last-minute issues. While the launch license from the Federal Aviation Administration, FAA, has yet to be granted, Elon Musk's predictions suggest smooth sailing ahead. The license is expected to be in SpaceX's hands within the next 3 to 5 weeks, coinciding with the anticipated launch time frame. Standing nearly 122 meters tall when fully assembled, Starship boasts impressive power. It consists of the Super Heavy Booster stage with 33 beastly Raptor engines and the upper Starship stage standing 50 meters tall, designed for future missions carrying both cargo and humans to the Moon, Mars, and beyond. Images shared by SpaceX depict the Super Heavy Booster securely held by the tower's grasping arms. Teams are gearing up for the upcoming static fire test, where all 33 engines will be fired in quick succession. The sight of stacked Starship is truly impressive and majestic. The performance of this colossal rocket has significantly improved after each test flight. The first flight lasted just 4 minutes due to the inability to separate the Starship stages. The second flight doubled that duration and achieved stage separation. The third flight lasted nearly 50 minutes but unfortunately ended with the upper stage of Starship breaking apart upon re-entry into Earth's atmosphere. In Starship's 4th test flight, SpaceX aims to achieve several important milestones not yet accomplished in the previous 3 launches. The primary goal is successful recovery of both the Super Heavy Booster and the Starship upper stage after flight. Currently, Starship 29 has completed 2 static fire tests, while the Super Heavy Booster 11 has also undergone a similar test once with its 33 Raptor engines. SpaceX might conduct additional spin prime tests or even another static fire test once both are integrated. After completing these tests, SpaceX may separate the 2 rockets and move them back to the production area to finalize the remaining steps, including finishing the heat shield for Starship 29. If the 4th flight is successful, it could pave the way for SpaceX to achieve the goal of conducting 6 to 9 Starship launches to support NASA's Artemis moon exploration program and SpaceX's ambition to build a city on Mars. With the Super Heavy now standing upright on the launch pad, all eyes are on SpaceX as the company aims to overcome the next major challenge in the revolutionary Starship development process. However, to turn the dream into reality, Starship needs to overcome numerous challenges, with one of the biggest being the heat shield system. The heat shield plays a crucial role in protecting the spacecraft from extreme temperatures and intense forces during re-entry into the atmosphere. Perfecting this system not only impacts the safety of Starship but also determines its reusability, a key factor in reducing costs and enhancing the efficiency of space flights. Though facing difficulties, they are by no means insurmountable obstacles for Musk and SpaceX. Progress in the heat shield system is evident, with adjustments such as resizing leading to significantly improved effectiveness, as seen between Flight 2 and Flight 1. By Flight 3, Heat shield issues mainly arose during atmospheric re-entry, a common challenge for all organizations. This indicates that the heat shield system is gradually stabilizing, and the remaining challenge lies in further perfecting the atmospheric re-entry process. Therefore, SpaceX consistently leverages valuable insights from flights and tests to upgrade systems, especially the heat shield. This proactive approach is evident in the countless upgrades implemented after each flight, such as over 1,000 changes after Flight 1. Additionally, any issues identified with the heat shield during testing are immediately addressed, as seen with S-29, where issues post-static fire testing led to replacement of the heat shield on the nose cone and other components in the main compartment. This proactive approach underscores SpaceX's commitment to enhancing the Starship heat shield system for future flights. SpaceX's confidence is bolstered by their ownership of the Dragon spacecraft, known for having the best atmospheric re-entry capability among current spacecraft. Test models like Endeavour have successfully completed 5 flights. Dragon's performance with the heat shield is evidence of SpaceX's capability in this field. Although Dragon is smaller than Starship, shared expertise in heat shield development instills confidence in SpaceX's ability to overcome challenges with Starship. Patience and continuous refinement remain crucial as SpaceX progresses towards perfecting the Starship heat shield. The heat shield system for Flight 4 will primarily focus on withstanding intense heat during re-entry, reaching temperatures up to thousands of degrees Celsius. With recent upgrades on S-29, it's clear SpaceX is paying significant attention to this system. The upcoming test flights will provide crucial detailed information on the heat shield's operational performance. Not only focusing on the 4th flight, SpaceX recently conducted a static fire test for Starship 30 at the B orbital launch site. Starship 30 is expected to undertake the 5th test flight along with Super Heavy Booster 12, which has completed 2 cold fueling tests. However, in another recent cold fueling test with Starship 31, according to a video recorded by NSF and posted online, an electrical malfunction seems to have occurred during the detanking process. Subsequently, John Cargyle captured a detailed photo of the malfunction, revealing damage to the electrical conduit on the ship. The severity of the damage and whether the ship can be salvaged remains unknown, but this is not entirely new to SpaceX as they have faced similar issues before and proceeded with repairs and subsequent test flights. I have full confidence that SpaceX will overcome all challenges. What about you? Do you think the 4th test flight could take place within the next 3 to 5 weeks as planned? Leave a comment below. Don't forget to like, share the video, and subscribe to the channel for continuous updates on interesting technology and electric vehicles. Goodbye for now and see you in the next video.